guys, today's problem is nearest exit from the entrance in the maze. So you are given an m cross n matrix of maze 0 indexed with an empty cell represented as the dot and the walls are represented as the plus symbol. Basically, if this matrix will look like dot dot plus dot dot plus dot 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 dot. Plus signs means wall and dot symbol plus means wall, dot means empty space. Okay, so we can move on the empty spaces. Okay, so in one step you can move a cell up. In one step you can go up, left, right and down. Okay, you cannot step into a cell with a wall. You cannot step into a cell with a wall, means we cannot we cannot travel to the wall. An exit is defined as, and what is our goal in this problem? To find the nearest exit from the entrance. Find the nearest exit from the entrance. An exit is defined as an empty cell. Exit की definition क्या है? Exit की definition है एक empty cell होगा जो कि border पे होगा. The entrance does not count as a exit. This highlighted thing is much important in this problem to solve all the test cases. I will tell you why in my code. Return the number of steps in the shortest path, as it is saying shortest. By the shortest mean we will move to the BFS, because it can only in this kind of the problems we will choose the BFS because it will give us a correct answer from the entrance to the nearest exit. Because there are some chances कि हम DFS लगाएं और हम लूप के अंदर फंस जाएं या कुछ भी, whatever the cases. So we follow the Q BFS because it is mentioned shortest path. So any problem of the matrix which is saying find the shortest path, choose blindly BFS. Okay, so now we have to return the number of the steps into shortest path from the entrance to the nearest exit, or -1 if there is no path. Okay, so let's look at the first example given by the problem. If I am standing at here, so where I can go here, I can go here, though these two paths only. If I'm come here from this point, I cannot move outwards. By this point is an empty cell and this is on the border, so it is satisfying all the condition of an exit gate. Okay, exit gate की जो definition थी वो ये वाला पॉइंट अच्छे से फॉलो कर रहा है. इट इज़ एट द बॉर्डर एंड इट इज़ अ एम्प्टी सेल. आई कैन मूव इन वन स्टेप. ओके, and I can move to this empty cell which is on the border or the exit. It will take me 2 steps. So what I have to return? I have to return the minimum. So minimum will find at this point. Okay, so the answer will be 1. I can jump only one time. Okay, so one more example I am giving to you. What happened? This is the example number 3rd in the problem. If the girl is standing here and there is a wall, so what is the answer in this case? I cannot move upward, I cannot move down left, I cannot move downward, and I cannot move here. So this is my stick position. Stuck here. I am stuck, means I cannot find any path, I cannot find any exit gate. So the answer will be -1. And take one more example. In that example you are given this is also the example given in the problem. My girl is standing here, G, and this all are walls, these all are also walls. So we have to find the empty path. You know what I was thinking in the first attempt of this problem? I was thinking this girl can move. This girl is already present at the exit point. This one is the exit point, and I will return the 0. But I misunderstood in this question, but it is clearly mentioned entrance does not count as an exit. So keep this in mind. So this girl can move to this position. These two are the dot. So we can move in 2 steps, 1 and then 2. So this will be my exit point. Okay, and the answer will be 2 in this case, not 0. Okay, so question understanding is done. Now we will move at question part. The way I will apply BFS. How will I apply the BFS? I will take a dx and a dy, two arrays for example, if I am standing at 0, 0, then what is my upward direction? -1, 0. Downward is -1, 1 and 0, and here 0 and 1, and here 0 and -1. Understood? So what do I fill in my dx? For the movements, because I can move only in 4 directions. So I will initialize my dx and dy upwards for the movements, and we will apply BFS in this problem. And how we will apply? We will first of all, I will take a distance name and sx, sy, sx. We will store sx. We will store the initial position of the girl in sx, sy. For example, here, what is the point? What is the point this girl have standing? 1, 2, 1, 0, because it is saying it is 0 indexed. So this one will be 0, this one will be 1, this one will be 2. So I am at 0, 1 and 2. So this position will be 1, 2. So I will store this in my initial position sx, sy, and I will start applying BFS. How? I am telling. So in the BFS, I will take a Q. I will take a Q of vector of int type. Why? In this I will push the starting one. How? Q dot push. Our basic Q, whatever we are done in. So yeah, we will insert our first element, Q dot push sx. We will keep this in a vector form, sx, sy and 0. Initial distance is 0. Okay, Q dot push this, and after that इनिशियली क्या है मेरे पास क्यू में 1, 2, 0, and what I am doing, I will check all the possible cases. You can see in the I will check all the new directions. If I am standing here, I will calculate the upward, I will calculate the left and right and down, and I will check if these points are safe in my condition. What are these points will be? If this is 1, 2, then upward is 0, 2, downward is 2, 2, leftward is 0, 2, and rightward is this will be this. What will be this? 1, 1, and this 1, 3. So I will calculate all the four directions and will check if this one is valid or not, if this one is valid or not, if this one is valid or not, if this one is valid or not. So in my first example, these two are valid, these two are not valid. Okay, so I will push these two in my queue. Which one? 0, 2 and 1, 1. 0, 2, 1, because I move ahead in this case, and 1, 1 with one step. Okay, and I will pop from the queue. Okay, these two are my current ones. Okay, so what I will do now, I will check 0, 2, 1, and I will explode, and I will mark this one as mark this. One more thing, we will take a visited, we will make a visited matrix, and I will mark this 1, 2 position in the visited array. 1, 2 position equals to plus. I am using the maze. I will mark this as positive so that I cannot move at this point again in future, because if I will, then I will stuck in the loop. I will come again and again at the same point and I will not find the answer correctly. So 1, 2 is true now, means I cannot come again at this position. And now I will be checking this thing, this point 0, 2, 1. So how many positions? 0, 2, 1. So I cannot move upward, I cannot move back. Wait, I cannot move upward, I cannot move at this position, because I came from it and I already marked it as a wall. Okay, and I cannot move at this, I cannot move at this. So what is the only one position? This one is the position. Okay, so what I will do, I will remove this from the queue and insert 0, 1, 2. Okay, in my queue, and I will again, after popping this and pushing this, now I will move where? I will move to this position 1, 1, 1. So I will so from 1, 1, 1, from here this position is already this position is fulfilling all the criteria to be an exit gate. Wait, what are the criterias? It is an empty cell and it is at the border, and that's it. It is an empty cell and it is at the border, so it is fulfilling the condition. So this one is exit point. So I will return from here. I will check if this point is in my code. I will show you. So first of all, what I was saying, I will maintain a dx, I will maintain a dy globally, because I am using to fetching all the four boxes indices. So, and I am checking is safe also, where I am passing I, j and vector of the visited characters. Okay, so if my I is less than 0 or my j is less than 0, if my I is greater than equals to m, means my boundary condition से भी बाहर अगर जा रहा है, and if my j is also greater than equal to n and my visited of ij is plus, so I will say false. I cannot place my girl at this position because this is not the safe position for her. So this is my else all the conditions I will say true. And this is our given API in the question nearest exit. So I will first of all check the m and n. What is the m cross n? If because of this m cross n matrix. So I need to find m and n both, because I am giving only image. So it is like this thing. This is my n and this is my m. Okay, so at 0th index, what is the size of the one matrix, what is the size of the one array is stored in the m. So sorry, this is my m and this is my n. So whatever I am storing in this 0th index, what is the size of this single vector is stored in my m, stored in my m, n, and this whole vertical size will be stored in m. Okay, so these two are my entrances, sx, sy, what I have already told you in explanation, and distance is 0. I'll take a visited and I am marking all the positions same as the maze, because I am just taking the reference from the, I am just copying the maze to the visited, because I am marking the positions which I already visited with plus symbol. Okay, so initially my q is q, what I maintain vector of int, and q dot push is sx, sy and 0. Visited of the sx, sy is true. Okay, true means plus symbol. Now this one is my wall, because of अभी इसको मैं वापस visit नहीं कर सकती. And after that I am doing BFS. So how? So while my queue is not empty, I will take the front and I will pop it, and I will take the values in my x, y, z. Now I am moving in all the 4 directions and checking my new x, new y and new z. And after checking my new x, new y, new z, I will check if this condition is safe for me or not. If this condition is safe, then I will check if my nx is equals to minus 1. It means if my nx is at a boundary, lower boundary or upper boundary, lower boundary 0 or m minus 1. So if my nx is at the border or at the initial, because these two considering as a edges, means an exit point, because these two are satisfying the condition of the exit point. So I am checking if I am present at that position, then I will return or this 0 or this n minus 1. So I will return simply my nz कि मैं पहुंच गई हूँ एग्जिट पॉइंट पे, मिनिमम डिस्टेंस को लेकर के. And I will push all the adjacent upward, downward, leftward and rightward positions in the queue. If these positions are safe, only it is the condition, only and only if the position is safe, I will push in my queue, and I will mark it as wall also, because I do not want to come at this position again in the future. Okay, so ऐसे ही इसको पूरा करना है. एंड आफ्टर दैट अगर मुझे कोई भी ऐसा पॉइंट नहीं मिला है एग्जिट पॉइंट वाला, तो मैं रिटर्न कर जाऊँगी -1. ओके, सो टाइम कॉम्प्लेक्सिटी ऑफ दिस, व्हाट इज द टाइम कॉम्प्लेक्सिटी? टाइम कॉम्प्लेक्सिटी विल बी v plus e. Time complexity will be, will be the time complexity? I don't think so. It will be v plus e. Time complexity will be m into n, m cross n, because we are visiting the whole matrix and we are checking all the conditions. We are taking one at one step. We are taking a one node at one time, and what is the worst case? Worst case will be I will be visiting all the positions. Worst case will be I will be visiting all the positions. So this will be m cross n, time complexity will be m cross n. So that's it. This is the code, this one is the explanation, this one is the explanation, and that's it. Okay, thank you guys.